Good afternoon, everyone. So, yesterday I couldn't take the class because of some personal issues. So, we will compensate that class sometime in next week when you are free. I will inform you in advance. Okay. In the last class, anyone remembers what we were discussing? We were discussing about data types, right? Data types in C. Any data we use, typically numbers or strings. Any data we use in a C program should have some data type associated with that, and the basic or primary or fundamental data types in C are five. There are fundamental data types in C: integer, character, floating point, double, and void. And we were discussing about that. We saw some example for integers. Then I showed this diagram to you. When you write a program, type it, save it as a file, execute it. What is the workflow? How these components are involved? These are the main parts of a computer, and how these computer parts are involved when you are typing a program, executing it, etc. And the videos of these classes are already shared with you. If you have any doubt, you can go back to those videos and watch it once again. And still, if you have doubts, you can get back to me. You can discuss with your friends in your WhatsApp group, etc. Now, size of a data type or a variable, I explained that concept also. When a data variable is created, some memory in the primary memory of the computer, some memory should be reserved. Normally it is in bytes, 1 byte, 2 byte, etc. Okay, so that is what size of a data type. How many bytes are reserved in the memory when a variable of that data type is created. So typically on a 16-bit machine, integer will have 2 bytes. On a 32-bit machine, an integer will have 4 bytes, etc. It is not fixed, depends on the computer. Most of the computers these days are 64-bit machines or 32-bit machines. So an integer will have 4 bytes. A character will have 1 byte. This is the representation of the memory and the units of memory starting from bits. 8 bits are 1 byte, 1024 bytes are 1 kilobyte, till the amount of memory you use typically in your mobile phone, smartphone, 2 gigahertz, 3 gigahertz, 4 gigahertz, or your flash memory 32 gigahertz, no, gigabytes, sorry, gigabytes. Then computer system will have secondary memory typically in the order of terabytes these days, 1 terabyte, 2 terabytes, etc. Okay, so that's the concept of size of a data type, basically in bytes, number of bytes reserved in the memory. Then we saw some modifiers to the basic data type like integer. You can have unsigned integer, short integer, unsigned short integer, etc. Some modification. So the size of the data type will vary slightly. So if integer is 2 bytes, short int may be 1 byte. Okay. So if your program doesn't require 2 bytes to be reserved for an integer, you can use short int. When you use that, when the numbers that your program process are very small, which doesn't require 4 bytes or 2 bytes, you can go for short int, and your program will consume less memory in total if you are saving on individual variables. Okay, in bit by bit or slowly, like in small quanta you save in memory, overall your program will consume lesser memory. That is considered to be better. Okay, so this modifiers we can use for integer. When character has unsigned and unsigned character, when float doesn't have any modifier, but double data type has a modifier, that is long double. We saw that when double is 8 bytes, long double was having the size 16 bytes. That means you can store large values in a variable of long double type. We saw creation of variables, we already know. In programs we have seen how we create different types of variables, integer variables. So 4 bytes are reserved for in my machine, since it is a 32-bit machine. 4 bytes are reserved for this. Even for float, 4 bytes are reserved. when I do use a double, it reserves 8 bytes. So float and double data types are basically for storing real numbers. Float we use for relatively smaller real numbers. Double we use for larger real numbers. Okay. Then integer data type will continue from here, and slightly concept wise I think you are clear. Any doubt is there, you can raise your unmute and speak to me. If you uh, type in chat box, I cannot see since I am in a different window. I have to go to this and then go to your chat box, then only I will come to know who has typed a message. So I will not come to know. Still I am finding only less attendance today, 24. I wonder why it is. Any reason specifically? It's already 12:48. Okay. Anyway, attendance is important. I will consider all these things at the end when I'm uh, making you marking your final attendance for the semester and examination eligibility. Okay, integers are whole numbers with a range of values. There are signed and unsigned integer. I already told you. Unsigned integer means only positive numbers, 0 and positive numbers. You can create it using unsigned int. Unsigned int. Okay. The difference is that there will not be any bit reserved for storing the sign. Otherwise, when you store a integer, normally as by default a signed integer, one bit will be used for indicating the sign of that number. 0 is used for positive numbers, and 1 is used for basically machine language. In machine, one bit is used for storing the sign, and the value in that one bit will be 0 if it is a positive number, 1 if it is a negative number. That is how we differentiate between positive and negative numbers when we store it in the memory, in the computer memory, because computer memory has only zeros and ones. So the first bit is treated as a sign bit if it is a signed integer. For unsigned integer we can ignore because all are positive numbers only. We will not reserve a bit for storing the sign. Okay. So unsigned integers are always positive, 0 or above. They do not reserve any bit for representing the sign. In case of unsigned integer, they use all bits for storing the magnitude. Since we don't reserve any bit for storing the sign, all bits can be used for storing the magnitude. So if there are 2 bytes for an integer, that means 16 bits, all of them will be used for storing the magnitude in case of unsigned integer. If it is a signed integer, 1 bit will be reserved for storing the sign. That means only 15 bits are available for storing the magnitude. That means the range of value, the largest value we can store in an unsigned integer will be smaller than the largest value we can store in a signed integer. Signed integer will be smaller than what we can store in a unsigned integer variable. Okay, because in signed integer 1 bit is used for storing the sign, and only 15 bits are used for storing the magnitude. In unsigned integer, all the 16 bits are used for storing the magnitude. So, and only positive numbers are there. So the largest value will be almost double than the largest value we can store here in case of signed integer. Clear? Any doubt? Okay, different variants already we have seen. Short int, the default int, that means signed integer. If when I specify int, that means signed integer. If I have to use unsigned integer, explicitly I have to use this keyword unsigned int in the declaration of the variable here. Instead of this I have to use unsigned int. Okay, if I have to use only positive values, or I want to store only positive values. Then normally short int is the smallest, then int followed by long int, which is the largest amount. So short int modification to the normal integer, then the normal integer, and long int. So short int, long int, unsigned, etc. Short, long, unsigned, etc. are called modifiers for the basic data type int. And these are also keywords in C language. So we have seen so many keywords now: short, long, unsigned, float, int, double, etc. So the size of the data type is the number of bytes or memory space reserved for any variable, of that type. Typically, if I represent the size of a short int or int or long int, relatively it will be like this. Short int is the smallest, int is somewhere in the middle, long int is larger. That means more bytes are used for long int type variable. Then for an integer, how to get or compute the range of value it supports, or the range of value that we can store. The smallest number and the largest number we can store in an integer variable. Okay, there is a way to do that, and it is depend on the size of the data type. That means how many bytes are reserved for that variable. Okay, now we take the case of a signed integer. So signed integer, the equation is minus 2 to the power n. That will be the smallest number we can store in a signed integer, and the largest number we can store in a signed integer will be this, plus 2 to the power n minus 1. Okay, then what is n? N is there is only one variable here in this formula. So n is the number of bits available for storing the magnitude. Number of bits available for storing the magnitude. So if my size of my integer is 2 bytes, n will be what? Can you tell me? Size of my integer is signed integer. Integer means signed integer by default. So what will be the magnitude, or what will be the value of n? Can anyone tell me?
So 1.
No, it's actually number of bits. Number of bits available for storing the magnitude. 2 bytes means what? I am talking about 2 bytes. Size of integer is 2 bytes. That means 16 bits are there. In that 16 bit, 1 bit I am going to reserve for storing the sign. That means how many bits are remaining for storing the magnitude?
15 more.
15, yeah. So out of 16 bits, 2 bytes means 16 bits. 2 into 8, 16. 16 bits. Out of that, 1 bit I am using for storing the sign. So 15 bits are available for storing the magnitude. So the lowest value I can store is minus 2 to the power 15. If my integer is 2 bytes, signed integer is 2 bytes. And the largest value I can store is 2 to the power n minus 1. Okay. So we will see an example, or no. Okay. Yeah, here is an example. Integer or signed integer, assuming that size is in bits, size is 16, or that means in bytes it is 2 bytes. The range of value is minus 2 to the power 15 to 2 to the power 15 minus 1. Okay. So if you convert it, if you find 2 to the power 15, it will be minus 32,768 to plus 2 to the power plus 32,767. This 767 because I am reducing 1 here from 2 to the power 15. Okay, so that is for signed integer. This equation is for signed integer, smallest value and the largest value, and this is the range, this to this. What about unsigned integer? In unsigned integer, what I told, if size of the integer is 2 bytes, that means 16 bits, all the 16 bits are used for storing the magnitude. Unsigned integer, it is obvious that we have only positive numbers, or what we treat whatever we value store in a variable, unsigned integer variable, as positive numbers only. So there is no bit reserved for storing the magnitude. By default, all of them are positive numbers. Because of that, we have all 16 bits available for storing the magnitude. So in that case, the equation smallest value will be 0. Smallest positive number we consider is 0. Other than that, below that all negative numbers. and the largest value will be 2 to the power n minus 1. But the difference is that here value of n is 16. The number of bits available for storing the magnitude is what n is. So we have 0 to 2 to the power n minus 1, where n is 16. That is the range for unsigned integer. The equation for unsigned integer, formula for unsigned integer. So here we consider unsigned integer. Size is 16 bit or 2 bytes, our assumption. The range of value will be 0 to 2 to the power 16 minus 1. That means if you consider computes 2 to the power 16, it will be 65,535. 2 to the power 16 minus 1 is 65,535. Similarly, short int, that means signed integer. Short int is 1 byte. If your int is 16 bits or 2 bytes, short int will be half of that roughly, most of the time. I am giving an example. The exact values on a compiler, on a computer system, it will vary. These days, many systems, the integer is 32 bits or 4 bytes. So accordingly, this will vary. If it is 32 bits, this value instead of 15, it will be 31. Okay, instead of 16, it will be 32 here. If your integer is 4 bytes. Here, to keep it simple, I am assuming that my integer is 2 bytes. So in that case, short int is 1 byte. The range of unsigned short int is minus 2 to the power 7 to 2 to the power 7 minus 1. That means minus 128 to plus 127. Signed one, sorry. So, signed short int. Unsigned short int, all 8 bits are available for the magnitude. So 0 to 2 to the power 8 minus 1. Okay. Long int, assuming that 32 bits, long int is 32 bit, 31 bits are available for magnitude. So minus 2 to the power 31 to 2 to the power 31 minus 1. So this will be the value. The upper range will be this. The largest value, the smallest value. Likewise. Okay. So we have this thing, signed integer, unsigned integer. Formula remains more or less same, except that for signed integer, the range is starting from minus negative value minus 2 to the power n. But for unsigned integer, it starts from 0. The upper range, upper bound or upper largest number remains the same. But for signed integer, n will be 15 in case of 2 byte integer, and for unsigned integer n will be 16. So, any doubt in this? Any doubt?
No, sir.
Okay, still 33. Okay, we'll stop the discussion on integers. We are discussing about integers only. Then character, next basic type, integer, character, float, double and void. Character variable we create using the keyword char space the variable name, char x, char y or whatever. And the example for character constants I told already. Anything within any single symbol, normally any single letter or symbol within single quotes, it's a character. There are some special characters like new line, which will have 2 symbols but still considered as a single character. These are having special meaning, you know. If you, when you are displaying on the screen, if you want to commit in the message to come in a new line, you have to insert a new line /n character in the print message, printf function. Then /tab is a tab character is a group of blank spaces, typically 4 blank spaces. This also I demonstrated in one of my previous class. Okay, single quotes. Normally single symbol within single quotes. This is not a character. 2 symbols are there, and if you use such things, the compiler will give you an error. Okay, but this is a special character. This is also a special character. Compiler will not have a problem. Okay, few more such special characters are there. /0. That also is there. Then how you create a variable and assign a value. So char a is equal to the character constant value. Then choice, my variable name is choice and assigned with a value. Similar to what we do with integer. Sometimes we will assign a value. Sometimes we can leave without an initial value. Here I have an initial value. Here I don't have an initial value. Both these are valid. Sometimes in your program you may need an initial value. Then you can assign an initial value. Okay, here I declared two variables, two character variables, and initialized both of them. And character can be signed or integer, doesn't make much difference for us. In a way, a character variable type, data type belongs to the family of integer data type. So that's why it can be unsigned or integer, unsigned or signed character. So, there will be 1 bit reserved if it is signed. That means only 7 bits we can use for storing the actual value of the character. Actual value means the ASCII value of the character or the binary equivalent of that character. In computer hardware, everything is in binary. Even if I put as a symbol here, finally it will be stored in ones and zeros corresponding to this, and we call it as an ASCII number. ASCII number. So there is a mapping for this. For each such character, there is a corresponding number for that, and that we call it as an ASCII number. It's an integer, 7-bit integer, and that will have a corresponding binary equivalent. Any number can have a binary representation using zeros and ones. Okay. So character can be signed or integer. Essentially, internally a character is of it belongs to the integer family. Okay. So here it is integral type. In that integer as well as characters are there. Okay. So family of character is actually internally integer. So unsigned char variable, the integer value that we can store is 0 to 255, assuming that character is 1 byte. But if it is signed character, the value we can store are minus 128 to 127, because 1 bit is used for storing the sign. This is in terms of the number equivalent of a character. Every character has a number equivalent so that it is possible to store it in the computer memory in binary format. And that they are called ASCII values. Okay, so much about characters as of now. And when you want to read a character using scanf, you have to use %c. When you wanted to read an integer using scanf, you use %d. But if you want to read a character, you have to use %c. This is also the language convention or the rules of the language. Okay. So then coming to the floating point type are used, as I said and as I demonstrated in the example, it is used for floating point data type is used for storing real numbers, and float is the keyword. Float is the keyword. On a 32-bit machine, we have seen what is the size of a floating point variable or floating point data type. We have seen that. We had an example here to check the size of different types. Okay, so integer we found that it was 4 bytes. Float we found it was 4 bytes. Double we found it was 8 bytes. Then char data type we saw it was 1 byte. So if I execute, it is not executing. Yeah. So we had seen this. Now if I change double to long double, that also we saw. Applying a modifier to double and making it long double. Right now it is 8 bytes. If I change it and I execute it again, compile it, execute it, I get 16 bytes. So double can store really large numbers. if required. So float is also 4 bytes on a 32-bit machine, but double is 8 bytes. Integer is also 4 bytes, but real numbers are stored in a different way compared to integers. Integers directly the binary format of that. Any integer can be converted into its not only any integer, any number can be converted into its binary. Any number in decimal system can be converted into binary system consisting of ones and zeros. Okay. So I think you are learning electronics fundamentals in this semester, right? In electronics fundamentals, you will learn how to convert a decimal number into binary system or binary to decimal system and hexadecimal system, etc. These are related to computer science and programming. Computer science and programming. Then the next type is double, basic data type. So far we have seen integer, character and float. Double is used for storing larger real numbers. So the number of bytes reserved in memory will be double, normally twice than float. Twice is 8 bytes, 4 bytes, double will be 8 bytes. But that is fixed for a computer architecture. We cannot change it. Okay. Then modifier long can be used for long double, as we saw in this example. Long double, it will reserve 16 bytes, and you can store really large numbers required for scientific computing or in engineering applications. 16 bytes for the long double data type. Okay, how you create is similar to how you create floating point variable. Instead of float, you declare double. Instead of float, you can use double. Okay, this is how you create double variables. So most of your task, your work with respect to C programming language, you can manage with floating point variable only instead of double type variable for storing real numbers. Then relative size of different data types: float, 4, double, 8. An example. Okay, in all architecture it may not be like that. It will keep varying. And size means the number of bytes. Double is larger than float, typically double, twice than that of float. Long double is again twice than that of size of the double. Okay. Now, any doubts so far? Occasionally you respond so that I'll feel that you are there and I'm also motivated. Otherwise I'll feel so. Still 31. I will catch these people. Okay, last one is void data type. It is slightly different from what we have seen so far. For every other data type, we can create a variable, or the main purpose of that is to create a variable. And these variables are used for storing data, which normally typed in by the user, the one who is executing the program. But with void data type, we cannot create a variable. Say void x, we cannot do. This is normally used in when we are creating our own functions. Suppose I am writing a function to compute the average of certain numbers or n numbers, or finding the largest of 3 numbers, finding the average. I have to specify what is the type of the output of that function. Okay, here in main I have specified the output of this function, or the result of this function is an integer type. Sometimes when you write a program, you want to specify that the function is not returning any result. That is also possible. The function is not returning any type. In that case, to indicate that, we can use void. So void is a data type to represent no data, and it is specifically used when we are writing our own function. Suppose I am writing a function of my own, say int add something. So it will typically look like this, and I can write my code here. That is also possible. Now here I indicate that result of my function is an integer. What if I want to indicate result of my function is nothing? I don't have any output or any result. To indicate that, I can use the keyword void. So that is the use of void, primary use of void. You cannot create a variable void of void type. This is invalid. If I try to do this and compile the code, compiler is going to give me an error. This red mark is indicating an error. Okay. So void is a special data type. It cannot be used for creating a variable, but it is used to specify a user defined function is not returning any result, to imply nothing is returned by this function or nothing is resulted by this function. Okay, is it clear? Void. Is it clear? I should start directly asking. Anusri, is it clear? Use of void.
Yes, sir.
Okay, then Meghna. Yeah. Okay. Now that is a good question. In fact, so I had a function here, and I am specifying it is not returning anything, result of this function or return value of this function. But in this function, still I can do some task. I can accept 2 numbers from the user or 3 numbers from the user, or I can print some message. So this function is doing some task. The only thing is that as an outcome, we are not returning any value. Here my main function is doing a lot of things, right? It is getting 2 data from the user, adding it, displaying it. But as an outcome, what I am returning is nowhere related to what I am doing here. I am not returning the sum. I am just returning 0. So here it indicates what this function, after doing all these things, what this function returns. I want to specify it is not returning anything. But it doesn't mean that that function is not doing anything. I can make any statement. I can write any valid C statement here and make execute. Okay, understood?
Yes, sir.
Okay, so such questions are, yeah, tell me. Here, yeah, this when I am executing this, see, I have to, when I create a function, it is little advanced concept. When I create a function, I have to call that function. Here printf is written by somebody else. I am calling it. I am not writing printf function or the definition of that printf function. Here void I created, and I write the definition also. Now if that has to execute, I have to call it from this my main function. If I call it from my main function, that will execute. Otherwise it will not execute. Okay. So if you want to see that, I'll compile this. I'll execute the code. So initially it is expecting me to enter 2 numbers. Now here you see whatever I am printing in add, it is coming. Understood?
Yes, sir.
So if I put a slash n here, it will be more explicit. Okay. It will come in a new line. So this will be anyway in my main function. Main function is the first function that will be executed. All other function you have to call from main. So here In main function, first it is expecting two numbers from the user and it is finding the sum. It is displaying the result. Then add function is called, which I created. I defined and the message is printed. Now if I remove this line, how do I remove? I'll just comment it out. That means no such line is there. Compiler will not see this. Any comments compiler will ignore. If I do this, again I compile and execute, that string is not coming. The string is not coming. So in such case, my function can do some work. Whatever we want. I can again get another two numbers here and add them. Whatever I want, I can do here. This void indicates that as a result of this, I am not returning anything to the function that called it. So here I am calling it here. To this, no value will come back as a result of that function. But this task, whatever I am writing here, will be performed by the computer. Okay, good question. You keep asking questions, then my enthusiasm and motivation level also will go up. Don't hesitate. Whatever doubt it is a genuine doubt and you can ask it. Okay, we will go back. So void is, we cannot create variable. We saw that there is an error. Okay, so there are some other use also for void type. We'll see it later. As of now, it is used to indicate the return value of a function when that function does not return any value at all. Otherwise, we will specify the type of the value returned: int, float, double, etc. Okay, so we'll proceed. Now, some statutory things. When we are scanning or printing, we used some %d, etc. Right? %f, %d. So whenever it was integer, for scanning I use %d. These are called format specifier or control string. Format specifier or control string. %d is for integer. So for scanning, or scanning means taking input from the user, or for printing, displaying output to the user, we used %d. Now what about for other data types? That is what is covered in this slide. Short int %hi or hd, unsigned short int %hu, character. So this you may not use so frequently, but character you will use frequently in lab programs. So %c, %d you already have seen. An unsigned integer, if you want to scan or print, you can use %u. Then long integer %ld, unsigned long integer %lu, float %f. We already used it in our add float program. We have already used %f in scanning the input or printing the output. Okay, if it is double, we can use %lf. %lf. If it is long double, we can use %LF. Okay, so most commonly we will be using the format specifier for character, format specifier for integer, format specifier for float. Okay, these three, these three I can say: %c, %d, %f. And in case you are writing a program which involves double, you can use %lf. Okay, and this is with respect to GNU C compiler. The C compiler we are using in code blocks or even in eBox. When compiler is a program only that converts our program, our C program, into machine language, and many companies will create this compiler software or compiler program by themselves. So from one company's compiler to other company's compiler, there will be small differences. Okay, that's why I specify these format specifiers are with respect to GNU C compiler which we are using. In your, those who studied programming before C, C++, etc., you must have used a Turbo C compiler and an editor, blue screen editor, and that is sort of outdated now. We don't use that. Mostly these days we use GNU C compiler since it is free and open source. Then Windows has its own compiler, and different compilers are also there. But most of the program will 99% of the program you write with GCC, it will work on other compilers also. You can compile with other compilers also. Compilation is the process of converting it into executable code. You need that. Then some statutory topics, declaration of the variables. We have already seen it, how to declare a variable, different types of variables, how to declare. Integer we have seen, float we have seen. If we want double, we can create using the keyword double and say give some name. You cannot repeat the name. If I have used X already, I cannot again use X for another type. Only once within a function. So I'll give a different name. If I want, I can initialize with a value. Otherwise, I can and semicolon, or I can omit that. Or both are possible. I can simply omit that. No, if you use X again, it is not going to compile only. When your output will come, after you have to clear all the syntactical errors in the program and then you have to compile. So it is not going to compile only. So it's giving me. And I can see that message also, what message is coming. I think I have shown you already. So conflicting type for X. So it says you have two X variables, one is having float and one is having double. Okay. So it will not allow you to compile your program. That means your executable file will not be generated for the latest modification you made. Okay. Yeah. So declaration, different types are there. In single line, you can declare multiple variables, or you can use one variable only. Okay. And if you want character variable, you can create characters char ch variable name. If you want initialize in single quotes, or if you don't want to initialize, simply leave. So this is how we create variables of basic type, and we can use scanf message to read input from user for all these types. So float you will use %f, character will use %c instead of this, and you will say enter two characters. If it is an integer, we will use %d. We will say enter two integers, the display message or the prompting message. That is a difference. So again, we'll go back. Declaration of variables, different types, and all. Like it is by this time you should be very comfortable with. We have seen several example programs only. So this is the theoretical side of it. The format, general syntax, data type, either like int, float, double, etc. Then variable name 2, variable name 3, up to n variables we can use, where n is theoretically any number. Okay, then declaration of variables. Yeah, in older versions of C compiler is also a software or a program. So different versions of it will come, like your Android 4, Android 5, 6, 7, etc. or Windows 7, Windows 8, Windows 10, etc. Different versions of the compiler also will come. And in older versions of the compilers, it was mandatory that you declare all the variables in the beginning only. Before any executable statement like this, the declaration should be finished. All the variables should be created in the beginning only. Now in the recent compilers also evolved in the process. So variables can be declared anywhere, but just before the first use of that. So I cannot create float s here. I commented a float from here. I can declare it here before the use of that variable for the first time. Okay, that is what in place declaration. If I declare it here, what will happen? I am using it before declaring it. So this will give me a compilation error. Because the compiler will starting this program, this is a text file only with an extension .c. Compiler will start processing from the beginning of the file, top of the file, first line onwards. It will ignore the comment, then it will include the header file, then it will start compiling. Compiling means what? Converting into binary code. Then it will read this line, this line, this line, this line. So when it comes here, you have used a variable s, which compiler doesn't know so far, because it has seen only these things before. Since the variable is declared here, compiler has not seen it. Comment is ignored. Compiler will not see this. So it gives me an error. What error message says? S is undeclared. Error S undeclared. So I cannot do it here, but I can do it here.